Did you know that on average 2.5 months of math skills are lost over a summer break? Hi, I'm Jamie Huseman, and I'm going to discuss with you today some easy whole number addition operations to help your students succeed. We will review addition of whole numbers, and I will also introduce 4 properties of whole number addition. How many toy planes do John and Kathy have together? This question can be answered with whole number addition. A whole number is any positive number. The addition of two numbers is called a sum. This is shown in a set model. The 4 properties of addition are commutative property, associative property, additive identity property of 0, and the closure property, which I'll talk about on the next slide. The commutative property says that if you have 3 apples plus 2 apples, it'll equal 5 apples. But if you also take 2 apples plus 2 apples plus 3 apples, it will equal 5 apples also. The associative property says that if you have 6 of any item, it doesn't matter what order you put it in, it will always equal to 6. And then the additive identity property of 0 states that if you take any whole number and add 0, it will be that whole number. The last property is the closure property, and it states that any whole number added to any whole number will be a whole number. This can be seen on the addition table. Addition is everywhere in our day-to-day lives. It can be easily shown to our children by involving them in grocery shopping or folding laundry. Reviewing the addition table will help your children learn counting on simply by following this table. And they also learn by counting by twos if you'll follow that diagonal. In conclusion, let's review our vocabulary words. We've learned today the meaning of whole number, sum, commutative property, associative property, additive identity property of 0, and the closure property. I hope you've gained some math knowledge today. Simply review these skills to help your child maintain their knowledge through the summer. Now I'll hand it over to my group mate, Michaela. Thank you.
I'll be talking about subtracting whole numbers. When things are adding up in your life, start subtracting. I will be introducing 4 models of subtraction of whole numbers. Takeaway, miss, add in, comparison, number line or measure. Takeaway, Aaron has $10 and spends $7 for a movie ticket. How much money does Aaron have left? Bob has read 7 chapters of his book. If there are 10 chapters in all, how many chapters must he read to finish the book? The comparison model. Mike has 10 cookies and Tim has 7 cookies. How many more does Mike have than Tim? Number line or measure. model. Alex biked up a mountain trail 10 miles. 7 of those miles were biked after dinner. How many miles did Alex bike before dinner? In all 4 problems, the answer is 3, because we know the addition fact 10 equals 7 plus 3. For an example, Aaron's $10, when written as 7 plus 3, shows what a $7 movie ticket and the $3 still in his pocket. The account for all at 10 he had originally. The cashier in the box office took away 7 of Aaron's $10, leaving him with $3. The first problem is an example of taken away model of subtraction. Bob, having reading 7 chapters, wants to know how many more chapters he must read. For an example, how is on what number to be added to 7 to get 10? So the second problem illustrates the missing addition model as subtraction similarity. The remaining problem illustrates the comparison model and number line of subtraction. Now passing it over to Jared.
Thank you so much, Michaela. Now, what mathematical operations should people know how to do before moving on to any other form of advanced mathematics? That is addition and subtraction, of course. My name is Jared Homshek, and I plan on showing you how these mathematical operations can be demonstrated beyond simple mathematical equations. Now, first of all, how would you describe the term mathematical model? Well, the best way to describe it is simply as a pictorial representation of what would normally just be a simple math equation. This lesson will be delivered in 2 parts. First, I will introduce to you the kinds of mathematical models that can be used to solve a problem. I have 4. Afterwards, we will have an opportunity to formulate our thoughts on the usefulness of these models. For example, here we have the number line model, and let's say we wanted to do the problem of 1 plus 9. So 1 plus 9 equals 10, so start at 1, and then we go all the way over here to 10. We move over 9 spots in the positive direction. 9 spots in the positive direction. You'll have to forgive me on my writing here. Similarly, if we wanted to go back to 1, we would start with our 10 that we now have and take away 9 of the to go back to 1. This represents the equation 1 plus 9 equals 10, and 10 minus 9 equals 1. Now, if you are following along, I would encourage you to actually write out this number line on a sheet of paper and then maybe write up your own equation. Because if you practice now, it could help you along the line to better understand what's going on with these models and how they work. So follow along and try to come up with an example for each of the 4 models that I'll be showing you. And that's actually how I would use these models to solve the problem. It's just to move the numbers into a model like this and then just plug in the values and follow along. Next model is the takeaway model. Now here we have 9 blocks, but if we wanted to say take away these 4 blocks, you would only have 5 blocks left. Similarly, if we got rid of these, you would have your 9 blocks back. Now for the add-in model, this one you're actually finding the missing objects to come up with the answer. For example, if we were to do the equation 5 plus 3 equals 8, well, we know we have our 5 here, and we have 3 other triangle bases that we're adding. You can find out that there are a total of 8 triangles here on display. Now, and finally, we have the comparison model, which is just comparing 2 different objects to do, you could do all sorts of different things with it. You can find out the total number of objects. For example, there would be a total of 9 objects here. Or you could also do it with subtraction. By you have 9 total objects and you know you have 6 suns, that means the other 3 objects must be moons by comparison. Now, what is the function of a mathematical model? Well, to me, this just represents a way to kind of represent it in not necessarily a practical application sort of way, but it's kind of putting it in terms of real life things that you could see in your daily lives, like suns and moons, or toy cars, or pizza. Whatever you want to use, putting it into real life terms can make the math so much easier to understand. And how would you design it to make it a multiplication or division problem? Well, you just put it in groups instead of just one item. Like, for example, if we go back here to our number line, and let's say we want to do -2 times 4. Well, you just do multiply -2 4 times. 2 times -2 times 1 is -2, then -4, -6, and -8. So there you have -2 times 4. Once again, I really apologize for this. Now, another question. Would it be better if students were able to solve these problems without using the models? To be honest, that's going to depend on the student themselves. Some students, they can just solve it themselves without having to look at pictures or anything. But others, they just cannot conceptualize these numbers. They have to have a visual representation to help them understand. And I'm not going to be upset if you can't use mathematical models. I understand that sometimes it's just easier to look at numbers and to find an answer on like a calculator. I'm that way myself, but at the same time, these models are designed to help you succeed. Now, is there a practical application to this? Of course there is. Matter of fact, a group of students at the University of Washington actually did a project where they created mathematical models to go and find real-world problems in their communities to solve real-world issues. Now, I have the link for you here, so if you write it down and put it on your browser, you can actually read it yourself. And matter of fact, I might actually encourage you to think about it, and maybe if you have the time or need to do it for a class, you could think about this and come up with your own model to help solve any issues that you might have in the community. And so what do you think? If you just feel free to share your thoughts either in the comments below and let us know what you think. I think, could be an interesting discussion. And that concludes our lesson on mathematical models. To begin, we were able to demonstrate our ability to display mathematical equations on various kinds of models. We also discovered that these models don't have to be used to solve a problem. Don't feel bad if you're not comfortable with these models, though. They're only designed to help students succeed and can be ignored if a student is more comfortable with solving equations on their own. Regardless of the methods that you follow, we hope that all of you continue to succeed in your studies. Thank you so much.